order to study descriptive statistics, the most important thing is you must understand the normal distribution curve. A normal distribution curve is called as normal because when you will collect the data from a normal population, which is not having any kind of problem, not having any kind of pathology, all the parameters or all the physiological parameters are normal for that population. When you will measure the data from that particular population, then you will form a bell-shaped curve like this. In order to form this curve, there will be two axes you have to form. There will be x-axis, there will be y-axis. The x-axis will always be an independent variable, and y-axis will be giving you the frequency. So once you will draw a table or a graph in between this independent variable and the frequency, then you will get a bell-shaped curve for a normal population. Just giving you one example, if you are going to measure diastolic blood pressure for a normal population, a mean of 80 mm of Hg, which is being recommended by the WHO. So this is what the mean value we know about it. But once you will measure diastolic blood pressure from the normal population, you will find or record that there will be some people who will be normal and having a low blood pressure, like ranging from 60 mm of Hg, and even there will be some extreme people which will be feeling normal but having a high diastolic blood pressure of like 100 mmHg. The lower one will be on the left side of this graph and the higher one will be on the right side of this graph. And then you will find like there is a large amount of people which will be centralized, having a range between 70 mm of Hg to 90 mm of Hg. So these bars are basically representing that how your frequency will be distributed. So there will be like some people with low blood pressure, there will be some people with high blood pressure, we can call it as extreme values, and then there will be a large number of people which will be centralized and will be having a blood pressure between 70 to 90 mm of Hg. So once you will join the mean of each frequency bar, then you will find it will form a bell-shaped curve, and this is the curve which will be representing that how your data is being distributed, which you have collected from the normal population. In order to understand the descriptive statistics, there are some basic terminologies and understanding of this normal distribution curve. Without that one, you will not be able to run any kind of descriptive or even inferential statistics. The first thing is you have to understand is the mean. The mean is the average of all the values you have gathered, and once you will make the average of that value, you will get a centralized value. In here, the mean will fall in this portion of the graph. Here it is written 0. I will explain it to you later. This is something related to the standard deviation. I will explain you what the standard deviation is. I'm talking about mean at present. When you will take the average of all the values, then it will be having a mean value which will be located in the very center of this graph. And then in a normal distribution curve, it has to be your mean, median and mode is equal if it will be having a normal distribution. The mean is the average, whereas the mode is the most frequent value, and the median is something which you will arrange your values in ascending or descending order, then you will get the most centralized value that will be called as the median, whereas the mode is the most frequent value and the mean is the average value. Okay, once you will make that thing like you have get the average, you will find like the mean will be on the very much on the center, then your values will be scattered lower than that mean and higher than that mean values. And in order to locate that value, we have another tool, standard deviation. Standard deviation is having a definition that means like the deviation from the mean value. So how your data or value is being deviated from your mean value, it will be explaining through your standard deviation. If the mean is located in here, then your standard deviation will be 0. That means your mean is equals to your that value. If that value is equals to your mean value, then there will be no difference. So that's why that will be having a 0 standard deviation. Once the data will be start moving towards the left side of the curve, remember one thing, the left side of your curve will be negative in standard deviation, and the right side of the curve will be in positive in your standard deviation values. The positive and negative will always be representing when you are going to quote any standard deviation. You must have to mention like your data is negatively and positively distributed in how much standard deviation. So you must have to write both the positive and the negative value. The normal distribution curve is basically divided into different segments. The first segment is the tip, and if you will move from the tip on the both sides, there is a curve or dome-like structure formed. This dome-like structure is covering a total area of around 68.26%, which is like 34.13% on the left side and 34.13% on the right side. And there is a straight line, which is inclined line, which will be counting for around 13.59% of the area. And if you will move from 0 to that area, which is the straight line where the straight line is getting an end, you will be finding a total area which will be accumulation of 34.13%, which is the dome area, and the straight line area is 13.59%, which will be counted for around 95% if you will be counting or summing up both sides of your curve. And the same is if you will continuing, there will be again a steep straight line or inclined line that will be reaching towards the level which will be called as the 3 standard deviation. And till here, the 3 standard deviation, your curve is covering around 99% of the area. So this is how your normal distribution curve is being formed.